Imagine this. A star, millions of times more massive than our Sun, collapses under its own gravity. The fabric of space and time begins to twist, stretch, and finally tear apart. At the heart of that tear lies something infinitely dense, a singularity, a place where the laws of physics no longer apply. But here's the strange part. According to Einstein's equations, that singularity should be exposed, naked, visible to the universe itself. Yet in reality, we never see it. We only see black holes, cosmic prisons that hide their singularities behind an event horizon. A perfect veil, a cosmic secret keeper. And that brings us to one of the most mysterious ideas in modern physics, the Cosmic Censorship Hypothesis. Proposed in 1969 by the legendary physicist Roger Penrose, the idea is simple, yet deeply profound. Nature abhors naked singularities. In other words, the universe somehow censors the most extreme breakdowns of reality from ever being seen by us. Every singularity, according to this hypothesis, must be hidden behind an event horizon. Why? Because if a naked singularity were to exist, if its raw, infinite gravity were exposed, then the laws of physics as we know them would collapse. Cause and effect could break down. Predictability would vanish. The universe would become chaos. Penrose argued that this cosmic censorship protects not just our equations, but the very logic of reality itself. To understand why this matters, we need to go back to Einstein's theory of general relativity. Einstein showed that gravity is an t of force pulling on objects, it as the curvature of space and time itself. A massive object like a star or planet bends space-time around it. The more massive it is, the deeper the curve. Now, imagine a star that collapses under its own gravity after it burns through all its fuel. For stars like our Sun, the collapse stops early. They become white dwarfs. For heavier stars, they can become neutron stars. But if the star is massive enough, no known force can stop the collapse. The space-time curve grows infinitely deep, and that's when a singularity forms. At the singularity, density becomes infinite, and space-time itself ends. It is not just that we don't know what happens there, it is that our physical laws can't even describe it. Normally, that singularity gets sealed away behind the event horizon of a black hole, the ultimate one-way barrier. Nothing, not even light, can escape it. It's as if the universe says, you can have your singularity, but no one gets to see it. That's cosmic censorship in action. But what if, just maybe, that censorship can fail? In 1969, the same year Penrose proposed his idea, another physicist, John Wheeler, coined the term black hole. Yet soon after, scientists began to find mathematical solutions in Einstein's equations that seemed to allow singularities without event horizons. These were called naked singularities. And if they exist, they would defy everything we know about physics. Because with a naked singularity, you could theoretically see the very core of space-time collapse itself. The laws of causality, what causes what, could break down. The future could influence the past. The universe could become unpredictable at its most fundamental level. It would be as if reality's code was suddenly revealed, but in pure chaos. So physicists asked, could these bizarre objects really exist in our universe? One possible answer came from rotating black holes, known as Kerr black holes. If a black hole spins fast enough, its event horizon can shrink. In theory, if the spin becomes extreme, the event horizon could disappear entirely, exposing the singularity. That would create a naked singularity. But there's a catch. According to the laws of physics, it seems impossible for a real black hole to spin that fast. There's a natural limit, known as the Kerr limit, that prevents it. In other words, nature seems to have built-in safeguards, rules that prevent naked singularities from forming in real life, almost as if the universe enforces its own censorship laws. But physicists are stubborn. they started thinking of ways to cheat the universe. Could we, perhaps, throw extra mass or angular momentum into a black hole to push it past that limit? A few daring theoretical papers tried exactly that, by imagining throwing a particle or a small black hole into a spinning one. But every time, something went wrong. Either the horizon stayed intact, or the equations balanced out to prevent exposure. It's as if the universe always finds a way to keep its secrets hidden. Penrose himself called it a cosmic conspiracy. Still, the idea of cosmic censorship remains unproven. It's one of the great unsolved mysteries of modern physics. To make things more interesting, in 2015, when the first images of merging black holes came through from the LIGO Observatory, scientists realized that the intense collisions created wild distortions in spacetime. For a fraction of a second, the event horizons of two black holes ripple, twist, and merge. Could that chaotic moment briefly expose the singularities within? Could we, for an instant, glimpse the naked truth of gravity? So far, the answer appears to be no, but the data is still young, and the questions still haunting. Now here's where things get truly mind-bending. In some theories, like string theory or loop quantum gravity, the singularity may not actually be infinite. Instead, it could be replaced by something finite but exotic, like a dense core of quantum geometry or a tangle of vibrating strings. If that's true, the cosmic censorship might not just be nature's way of hiding infinities. It could be hiding a deeper layer of physics, a hidden structure beneath spacetime itself. And, in that case, naked singularities might not be dangerous at all. They might be windows into the quantum realm of gravity, a realm we've never seen. In fact, some scientists are now exploring whether certain cosmic phenomena, like the mysterious fast radio bursts, gamma-ray flashes, or anomalous quasars, might hint at something stranger than black holes. Objects that mimic black holes but don't have event horizons. Some call them quasi-black holes, black stars, or even naked singularities in disguise. Could we already be looking at cosmic censorship breaking down without even realizing it? Philosophically, the idea of cosmic censorship also touches something deeper. It suggests that the universe has a sense of order, that it deliberately hides its own chaos from view. It's almost as if reality has a firewall, not just of energy but of logic itself. And that raises an eerie question. If nature hides its most fundamental secrets from us, what else might it be hiding? Are there parts of the cosmos we are simply never meant to see? Or is cosmic censorship just a temporary illusion, one that will crumble when we finally understand quantum gravity? In the end, whether the cosmic censor truly exists or not, it represents the eternal boundary between what we can know and what we cannot. The event horizon isn't just the edge of a black hole, it's the edge of human knowledge. Beyond it lies something infinitely strange, infinitely beautiful, and infinitely forbidden. Maybe one day our physics will evolve enough to pierce that veil. Maybe we'll find that the universe was never hiding anything, just waiting for us to understand. Until then, we remain the curious observers of a reality that guards its secrets well. And perhaps that's the universe's most elegant paradox, that its deepest truth is hidden in plain sight. This is Beyond Newton, where we don't just explore the laws of physics, we challenge the boundaries of what we're allowed to see,